is in the monsoon. So I will be doing on the monsoon climatology, and then whatever doubts and questions that you have in mind, you are welcome to address. So in my capacity, I will try to explain interaction. If you don't have a contrast, it is a monotonous, and then there is not much of a interaction that is taking place. Here you get the land and sea contrast that is there. So because of this land and sea contrast, you get, say, when you want to see a white, or I can say background, you have a black. So the background, it is giving the contrast, you are able to perceive the things. Here the land and sea contrast is the major. So therefore the ability of the land to absorb the heat, the ability of the ocean to retain the heat, that creates differences in the pattern, and that differences is the main reason for the monsoon to occur over the. Whereas in the Pacific and Atlantic Ocean, the sea is moderating, there's a moderating influence, the contrast is not pronounced. So it is a land and sea contrast is the one factor. And it is location in the latitude between 8 degrees north to nearly 38 degrees north latitude it is there. And then you have the peninsular characteristics. The area, it is not far away from the sea, it has the influence of the sea, and it is not a landlocked area. The third factor is the Himalayas. The Himalayas is the one which you all know is a barrier. It prevents the cold air coming to the India. Because of that, when the summer, when the sun is over the horizon, over the Tropic of Cancer, here you have intense heat is experienced, and then because of the intense heat, the low pressure is generated. So it is shut off from the influence of the cold air from the Asiatic mainland or China or Russia. It doesn't penetrate. Then the fourth aspect is the Tibetan plateau. Not only these Himalayas, but the Tibetan plateau playing an important role. And then this is called the Tibetan plateau. During the summer, it heats up, and then it provides a circulation which modifies the upper air circulation, and then it intensifies the drawing of air from the southern ocean to the Indian Ocean as a monsoon. So these and the orography, the Western Ghats and others, they are all favorable conditions for the occurrence of the monsoon. That is intensification of the pressure distribution, pressure differences, which draws the air, just like a land and sea breeze. It is an extension of the land and sea breeze. The contrast brings the monsoon. So this monsoon is, as I have mentioned earlier, that it is different from the general circulation of the atmosphere. I hope you are all familiar with what is a general circulation of the atmosphere. That is, you have the equatorial low, and then from the equatorial low, then you have the trade wind belts, then you have the subtropical high pressure, then the westerly belt, then the subpolar low and polar high. So you have the pattern, that is the general circulation of the atmosphere. In the tropics, you have the northeasterly trades and southeasterly trades converging at the intertropical convergence. That is the general circulation. The monsoon is a deviation from the general circulation of the atmosphere. That is, in winter, it is similar to the general circulation of the atmosphere. Northeast trades prevails, and then in summer, the northeast trades is replaced by reversal of the wind direction takes place. It becomes southwesterly. So it is a reversal that it is taking place, that it becomes a southwesterly. So it is a deviation from the general circulation of the atmosphere, and it becomes a regional circulation that you have in this area. Now, let me look into what are the conditions that are favorable for the occurrence of the monsoon. What is happening? Let us go through the time. Let us see what happens before the onset of the monsoon, what happens to the atmospheric circulation in the during the monsoon, and what are the factors that favor, because monsoon many has understood as the rain bearing winds. The rain is the moving factor. What factors contribute to the rainfall, and that I will concentrate now. Till now, if you have any specific question regarding the specific configuration of the land and sea which brings in the monsoon, you are welcome to ask before I proceed to elaborate on the conditions, atmospheric circulations that prevails before the onset of the monsoon. You have any questions? Any clarification or any comments?
Feel free to ask.
You can feel free, so that I can tell. And so now let me look at what are the. So the monsoon is a reversal in the wind direction, and it reversal in the circulation of the atmosphere. Let us look what happens, why the reversal is taking place. What are the factors, what are the conditions that are happening over the vast Indian Ocean that favors the formation of the monsoon currents. Now, the first and foremost is with the passage of the sun, when it is moving from the southern hemisphere, crossing the equator, and then move towards the north, with the shift in the sun's position, the energy received at the Indian peninsula increases. So, because of the high heat source, as I have already mentioned, that the heat is not modified by any air current coming from the colder Asian part. So this heat produces a drop in the pressure and a low pressure is generated. So this is a heat low. It extends from Somalia across the Arabia and then across India. Then it comes to the Indian peninsula. There is an extensive low. Pakistan and northwest of India, there is an intensive low pressure is generated. And then along with the low pressure, the Tibetan plateau also gets heated up. When the Tibetan plateau is about 4 kilometers high, and the 4 kilometer high Tibetan plateau, when it is heated up, it warms up the middle troposphere. You understand what is the troposphere is? It is the middle troposphere is heated up. When it is heated, what happens to the air? The air rises. When the air rises, because it rises to a certain height, and then it cools, and then it moves away. So you have a pattern, that is the air is rising, and then it is moving in two directions. Now, this has a very great influence on the circulation. When you want to know about the circulation of atmosphere at the surface, you should have an understanding of what is happening in the different layers of the atmosphere. Because it is a three-dimensional phenomenon. What is happening on the surface, what is circulation prevailing in the surface is closely related to what is happening in the upper atmosphere also. One simple fact is, that is when the air converges near the surface, it rises and there is a divergence. When there is a convergence is there, then there is an upper level divergence is there. If there is upper level divergence is there, then the circulation is on. Or if the upper level convergence is there, the air subsides. Similarly, in the month of May and June, when the Tibet is heated up, there is a upper level rising of the air, and then there is a upper level divergence is taking place over the Tibetan plateau. It influences the upper level flow, upper air circulation in the atmosphere. In winter, you all know that north of 30 degrees north latitude, you have in the upper air circulation, predominantly it is westerlies. On the ground, on the surface also, it is westerlies. At the upper level also it is westerlies. So the westerly air current is moving. And then in the westerly air current there are certain patches where the wind speed is very high, about 30 to 40 meters per second, nearly about 100 to 150 kilometers per hour, sometimes reaching more. And then such high velocity winds, pockets are there. They are called jet streams. And the jet streams, one, it is there in the tropical latitudes above 30 degrees north latitude, and then another is in the subpolar latitudes, it is there. So you have the two, when the jet stream comes, because of the barrier of the Himalayas and the higher Tibet, in winter, when the Tibet is cold, when there is no circulation, there is a high pressure is prevailing, one branch of the jet stream moves south of the Himalayas. Another branch of the jet stream, it is moved north of the Himalayas, and they converge over the China. So that we take, and now it is working?
Yeah, you're okay.
Yeah. So you see the westerlies. The westerlies, they move, there is the Tibetan plateau, and then there is the convergence zone, and then you have the easterly that it is there in the. I am talking about the upper level circulation at a height of about 10 kilometers, 15 kilometers above. That is, you have the westerlies. Then, when with the heating of the Tibetan height, this is called, you get the heating of the Tibetan plateau and the rising of the air and divergence. The divergence means it's associated with high pressure. So it is called as a Tibetan height. The Tibetan height is established, and then this westerlies move northward. The westerly jet stream, they move north of the Himalayas. So, and then simultaneously in the south you have the easterlies. This is the January circulation, this is the July circulation. You have the easterly, and in this easterly, so you find the rising of the air over Tibet. It moves both northward and it is southward. And then when it is moving in southward, what happens to the wind? What force is acting upon the wind when the wind is in motion? If your wind is moves, Coriolis force. Coriolis force, what makes the air? How it is acting on the wind? Yes, Coriolis force is there. If it is moving from Tibet towards peninsular India, in what direction it will? How Coriolis force affect the wind?
Northeast.
Towards the left, towards the right in the northern hemisphere, left is, yeah. So when it is moving from north to south, and when it is deflected, it becomes easterlies. So you have the easterlies gets intensified. Already it is there. It is get intensified. So then another thing is happening. In the month of May, you are in the eastern India. You are familiar with Kal Baishakhi.
Yes.
You are familiar with the convective showers that is taking place. What does the convective shower do? When a convective shower is taking place, what is happening? What happens to the water that is released as a rain? When condensation takes place, what happens?
Sorry, stop.
What is the latent heat of condensation? Do you remember the latent heat of condensation? What happens when the water evaporates? when it evaporates, the heat that is used up for evaporation is remain latent in the air. So similarly, when it releases, when it condenses, the heat is released. So the atmosphere gets an additional source of heat. One upper layer, because convection is taking place in the higher level. So in the upper air, that is the addition of heat is taking place. One, the Tibetan heat. Another is the convectional heat that is taking place. These two accelerate. When you become more energetic, you move faster, you run faster. The air also similarly moves faster, and then then the wind speed increases to jet level. So the air that it is coming, you have the appearance of the easterly jet. At a higher level, around 10 degrees north to 15 degrees north, at a height of about 15 kilometers, 10 to 15 kilometers above, you will find a strong easterly jet stream. So, with the passage of the sun, with the increase in the temperature, with the formation of the low pressure at surface, at higher level, you observe there are two phenomena occur. One is the northerly shift of the westerly jet stream from south of Himalayas to the north of Himalayas. Second is the appearance of the easterly jet stream. It actuates, that means the atmosphere is still, and then you have the heat. When the heat is there, the pressure drops in. There is a low pressure that is generated, and the intensive low pressure draws air from the neighboring. The sea, you all know, it gets warm slowly and releases the heat slowly. And then the sea, there is a high pressure. Land and sea contrast is dominating, and the air is drawn. And the pressure gradient is so high that it is able to draw air from across the equator. From across the equator that it is coming, and that it starts the movement. So before the onset of the monsoon, the establishment of the heat low, shift of the westerly jet from southern part of south of Himalayas to north of Himalaya, appearance of the easterly jet that is taking place in the upper atmosphere. Then over the Indian Ocean, because it is covering the large area, over the Indian Ocean, near equatorial trough, that is my
Right up.
Xerox is not come. Okay. Then over the Indian Ocean, you have the equatorial trough is near, that is in the monsoon. There is a equatorial trough. That means the convergence of the trade winds. There are two troughs occur, one at 5 degrees north and another is 5 degrees south. And then with the advance of monsoon, summer season, the northern trough dissipates. The southern trough, it gets intensified, and then it crosses it establishes a near equatorial trough, and near the Mozambique island there is a small high pressure ridge developed. So the presence of the high pressure, then the presence of the trough accelerate the movement of the air across the equator. And then this accelerated movement, it is coming as in the form of a jet stream at a low level, not very high jet stream, but a high velocity wind at 1 to 2 kilometer high, that is called the Somali jet stream. So this. So this diagram explains what I have explained, the establishment of the low, and then the displacement of the westerlies to the north of Tibetan plateau, then the formation of easterly jet. So the easterly jet is moving in the axis of the easterly jet, that it is moving, that it is there. So then the next one is Somali jet.
These are okay.
Yeah, this is the Somali jet stream which I have expressed. So this is the area, this air it is moving, and then this branch of the, here it crosses the equator, and if two branches it makes, one to the south of India, another is across the peninsula of India, that it is accentuated. So these are the points which I am discussing. So the formation of heat lobe, then near equatorial curve for mesocline high, and tip of the subtropical jet stream south of Himalayas to north of Himalaya, appearance of the easterly jet stream over peninsular area, and the formation of the Tibetan high. That takes place on the before the onset of the monsoon. If these conditions prevail, then the monsoon is accelerated, monsoon sets in. So when the monsoon sets in, then you have the other intensification of the monsoon and other aspects which I will be discussing. Any questions on these aspects which I will describe? Anything you like to? Anything?
Other students?
Am I clear in my exposition?
Sir, what about this Australian thing, that earlier idea that the monsoon used to come from Australia, originates from the north of Australia?
The monsoon, the earlier idea was that monsoon is crossing the equator.
Yeah.
But monsoon experiments were conducted over the ocean, and then very French and America and India, they all joined, and then the monsoon experiment was conducted. In the monsoon experiment, it was found that the balloons were launched, and from the Seychelles Island, the balloons were launched, and the trajectory was plotted, and it was found that large scale crossing of equatorial southerly winds north is taking place around this area. And then from Australia it is occasionally it is taking place, but the experiments conducted, observations that are made during monsoon experiments to show this passage as I have shown you here, large scale cross equatorial current is taking place across the Somalia, Mozambique, that stretch that it is taking place, and then you are having the flow of wind. So, and that it is not, earlier it was thought the entire southern wind crosses at all places and then it moves. But recent observations and with satellite images also, they accentuate, and then other phenomena which I am going to discuss now will also stress the point that the large scale crossing is taking place. So when a large high speed wind moves over the ocean, what will happen?
Pick up vapor.
When a large wind at a low level, the wind moves over the ocean, what will happen?
It brings moisture contents.
Moisture.
It brings moisture contents.
Moisture content. One it brings a moisture content. What happens to the ocean? What happens to the ocean? The upper layer of the water is drawn along with the wind. The upper layer of the air is drawn, upper layer of the water is drawn. When it is there is an upwelling is taken. Upwelling means there is a cold current. It is the water will be cold, and you find in the monsoon, during the monsoon season, when the monsoon sets in, there is an appearance of the cold Somali current that is taking place. When the cold current is moving over the ocean, over the sea, Arabian Sea, western part of the Arabian Sea, if it moves, then the air in contact with the ocean, it is colder. When a cold air is there, what is the condition? Whether there's air circulation, will it be stable or unstable? Will it be stable or unstable? When the cold air is there, it tries to sink. Density is high, it tries to sink. So when it is sink, it becomes hot. When it becomes warmer, it sinks, and then a cold air that is prevail over there. And then when it subsides, then what happens? When the cold air is subsiding, when it subsides, it's warmed up. You understand? That is, at the ocean surface level, the water is drawn because of that upwelling is taking place. And this upwelling causes the temperature, the sea surface temperature is cold. And then the air over there, because of the cold, subsidence is taking place. When the subsidence is taking place at a slightly higher level, that temperature increases. So you find over this area temperature inversion. The temperature inversion, if there is a temperature inversion is there, can the cloud form? The cloud cannot form. So you find 65 degrees east, that means you can visualize it, 65 degrees east, 65 longitude, you have a demarcation. To the west of the 65 degrees east, you find inversion, cold temperature condition, and then subsidence, and then you have the inversion. And to the east of 65 degrees east longitude, you have, by the time the temperature of the seawater increases, more intensive moisture, more moisture is brought, more evaporation is taking place, you have intense convective activity. So intense convective activity that is present, and then this intense convective activity reaches India, the west coast of India, and which gives rise to the which intensifies, brings in the monsoon. So you have, that is what it is, it is another next. This I already, this is already shown. This one. Here. Circulation is good. So now with this the monsoon sets in. During the monsoon, what is the type of circulation? Yeah. During the circulation of the atmosphere during the monsoon. So with the passage, with the intensification of the low, with the cross equatorial current, then you have the shift of the intertropical convergence zone from south of the equator to the north of the equator. Do you understand what is an intertropical convergence zone? Intertropical, yeah. That is the meeting of southeast trades and northeast trades. So you have the intertropical convergence zone. And this intertropical convergence zone, which was south of the equator, it shifts along with the passage of the sun, that it shifts to the north of the equator, and it reaches the India intertropical convergence zone. Air sea interaction, and this I have already explained. And then this, when the air current crosses, again as the Coriolis force, that it becomes the southeast trades, cross the equator and becomes southwesterly over the Arabian Sea. Then the southwesterly winds comes in the peninsular India, and then in Bengal, because of the formation of depression, which I will be discussing little later, it becomes southerly. And then with the passage of the movement of the depression towards the northwest, it becomes easterlies in the peninsular, in the northern plains, and then it reaches the Rajasthan and the other parts of India. So that is what is the surface winds in this thing. And this movement of the monsoon trough is the normally it is in position along this, you can take it probably along the Ganges, and that the trough it is occurring. When it is occurring, it helps in formation of depression, and the depression brings the rain. Just a minute, I'll take a little water. Because I have stressed upon the circulation, because that is the most important. That brings in the moisture, it brings in the moisture, and brings a particular condition of the atmosphere which is favorable for us. So we are more concerned about what are the rain that monsoon brings in, how it is distributed, and how we are. Let us look at it. What causes the rain? So the what causes the rain? Now, for rain, if you have any other questions, any clarification, am I making myself clear to you? If you have any way that it is okay. So now, what causes the rain? For rain to occur, what are the conditions necessary? Can you tell me? What are the conditions that are necessary for the occurrence of rainfall? Rain.
Condensation.
Huh?
Condensation of moisture particles.
One, it is for condensation to occur. What are the conditions necessary?
Convective movement.
One, it is the presence of moisture. Moisture must be present. The second is there must be a mechanism which lifts the moisture laden air to a higher level, so that when air rises, it cools. When it cools, condensation takes place. So the two conditions are necessary for the occurrence of rain. One, it is the presence of moisture. The second is a mechanism which lifts the moisture high above and then which causes the rain. Which makes the condensation possible. Condensation leads to cloud formation. Cloud formation leads to rainfall. Now, this condensation, so let us see in the monsoon season how these two conditions are fulfilled. Enough moisture is brought in by the monsoon currents. From the Arabian Sea, evaporation is taking place. From Bay of Bengal, evaporation is taking place. And also from the Southern Ocean, lot of moisture that it is transported. Some meteorologists feel that enough moisture is generated over the Arabian Sea itself and Bay of Bengal. The cross-equatorial current brings not that much of moisture. Some feel it. But actually it is the entire monsoon current. They bring in the moisture. So then the mechanism is, when the moisture is there, when humid, rain doesn't occur. Only the conditions that are favorable for the occurrence of rain must be present to lift the moisture laden air. What happens in the Western Ghats? How it rains in the Western Ghats? Why it rains in the Western Ghats so much? Why it rains in Cherrapunji so much?
Physical barrier Western Ghats.
Huh? Any other person? Can you just... Why it rains along the west coast?
The altitude of west coast is much higher, which obstructs the moisture.
Yes, that is the moisture laden air is obstructed by the barrier, orographic barrier. So that because of the obstruction, if the air rises, the rising air gives rise to a heavy rainfall.
10%.
Heavy rainfall. But the moisture laden air should reach Western Ghats, isn't it? In order to reach it and intensify it, along the Western Ghats, sometimes the trough at the mid-tropospheric level, that trough is generated. And the trough draws in more moisture and then that gives more rainfall. So the presence of, let us look at the weight-bearing systems. Yes. No, not this one. Yeah, it is not good. Please remove it. So, one, it is the presence of the intertropical convergence zone. And then that is called the monsoon. It is also called the monsoon trough. How do you identify the monsoon trough? In your map, you have the one. This is a weather map. It is called a synoptic weather map. It is called a synoptic weather map, which shows the condition of the atmosphere, the circulation of the atmosphere, and then it is a synoptic map. So you find in an active monsoon condition, the pressure, you see the difference in pressure. It is 1010 millibar or hectopascal. Nowadays it is called the hectopascal. So then it is 1010 in the southern part, and then you have the 990. So that is 996. 96. That is the variation in the pressure, in the pressure distribution. There is a steep pressure gradient is there, and you have the isobar. And a closed isobar is called a low pressure. Now you have two closed isobars, then it is called the depression. And when it is three cyclone, and then when the wind speed increases much more, it is called the cyclone. Now this is the depression, it is here. And then you find the isobars, they are turning. So where there is a curvature, it is there. Here it is the convergence of the monsoon trough. You see the direction of the wind. It is here, it is westerlies, and then here it is southwesterlies, and easterlies wind. Then it comes. So there is a change in the direction of the wind on the axis of the trough, and then this is called the axis of the trough. So the position of the axis of the trough draws the depressions that forms over Bay of Bengal into the India. So this depression, the monsoon depression, that is in Western Ghats, is the orography which lifts the air. In the plains of India, it is the formation of this depression and the position of the monsoon. When there is a low pressure is there, the air comes in there, and then it lifts the air, and then you have the monsoon depression, that it gives heavy rainfall. When the depression is there, normally in the southwestern part of the sector, that the rainfall is very high. So, and if the axis of the monsoon trough shifts to the foothills of the Himalayas, what will happen? That means the rain ceases. There is a break in the monsoon. So in literature we see the monsoon burst. Monsoon breaks over the Western Ghats. Now that meaning is different here. Here is a break in the monsoon, there is no rain that is occurring over the plains of India. But whereas the air is draws into the upper air circulation, the westerlies are still present. It may not be a jet stream, but it is the air circulation. The air is drawn towards the northeast. So when the axis of the monsoon trough is near the foothills of the Himalayas, then rain occurs in the Himalayas and the northeastern part of India. You get very heavy rainfall in the northeastern part, and no rain, very break in the condition, or no rainfall in the plains of India, and in peninsular India the acceleration is not much affected, it gets rain. And then there is a intense convective activity that is taking place in the northeast, and you have floods in the northeast and drought in the other part of India. So you have so what happens is the air is rising, as I again said, the rising air moves over the plain and then it sinks. You know about the circulation called Walker circulation. The Walker circulation also sets in motion, and then you have the air subsidence is taking place over the Rajasthan area, and Rajasthan does not get rain. The question is why Rajasthan is not getting rain. The main reason is the circulation pattern. There is a subsidence is taking place. There is a small temperature inversion is taking place which inhibit the growth of the cloud, and then you get dry conditions that it is given. So the movement of passage of the monsoon depression, that it is another important factor, and this depression that causes the rain over the plains of India. Then along with that, there is a one mid-tropospheric trough is there. That is, at a higher level, you have a trough, and then which causes mid-tropospheric trough, particularly along the west coast, and which moves across the west coast. It gives rainfall even to the interior of the rain, what we call as a rain shadow area. When this trough is present, in the rain shadow area also, the heavy rainfall that occurs. So, the three conditions: one, it is the position of the monsoon trough, the passage of the depression, presence of the vortex in along the west coast, and mid-tropospheric trough. These all causes the rain in India. If these conditions are not present, even if the moisture is adequate, the rain does not occur, very drought conditions occur. This sets into motion, and with the passage of summer, with the cooling of the atmosphere, with the southward movement of the sun, this circulation gets weakened up, the monsoon starts withdrawing. And then let us see this. So, this is the advance of the monsoon from 1st of June. Here 1st of June it comes in the Kerala, 5th of June in the middle of the peninsula India, 10th of June to the eastern part of India, 15th of June still to the west, 1st July and 15th July it occupies, and later with the passage of the thing it withdraws by September end, that the monsoon slowly withdraws and the northeast monsoon sets. So this how that it is happening. So to summarize it, that is, with the land and sea contrast creates an intense pressure gradient, and this intense pressure gradient and the higher heat that is received by the earth and also by the Himalayas changes the circulation pattern, and this changes in the circulation pattern is favorable, intensifies the pressure gradient, and which draws the air from the south to the north, and then which brings in the monsoon and gives the rainfall and the circulation, and these parameters are studied in order to make the forecast and analysis. Just I wanted to make it in a simple term without using any physics or anything, and then I hope I will be eligible up to till this point before I take up the monsoon prediction and then monsoon forecast and then the organization of the India Meteorological Department. I like you to have any interaction. Have I made my points clear, or if any points to be elaborated or questions are there, you can please ask me. Any other points, sir, which I have to cover up in the circulation pattern?
I think you are tired now. Please be seated.
Along the west coast, from 16th May to 30th September, how the rainfall that occurs. In a daily rainfall, you find this is the one that it is there. So these are the brain conditions which I have mentioned about. And then this is the rainfall pattern. Even 60 centimeters, 70 centimeters, you all know the cloud bursts that have occurred in Bombay, which resulted in about 90 centimeters of rainfall in a particular day, which caused heavy damages to the population. Such intense rainfall also occurs and also drought. And then here it is a pattern. That this is the drought that is occurring. These are the years where the severe drought that have occurred. And then you have 1987, that is one of the very severe drought, 65, 66, severe drought, 1980, very severe drought, 1980, 99, another severe drought that it is occurring. So, fortunately, in the last 10 years, in the decade, there is a good run of the monsoon. There is not much of a failure, except in 2002, where Gujarat and other parts of India experienced drought. The other part it is there. The good run of the monsoon might be over, and then it is a possibility, if the climatological records indicate the changes, then you will find that drought conditions may occur. Drought conditions may occur because in every once in 5 years or so, in a cycle, that is part of a drought conditions that prevent failure of the monsoon. Failure of monsoon means the depressions do not form, the cross equatorial current are not very intense, and then offshore flow of air might take place, which prevents the air circulation weaken, and the weakened circulation does not give rise to rainfall. So these are the pattern of the rainfall that it has occurred over India from 1890 to 1990 on. So then this monsoon, it is there. Just I'll take into one. So, if any other points, which I have to clarify or elaborate, can you tell me?
It is actually up to the students.
No, I'm asking you also. Because you have covered the portion. If it is a repetition, I may sorry that it is
No.
I couldn't make it more elaborate or etc. Yeah, any other aspects which are to be clarified, particularly on the circulation, before I take up the India Meteorological Department and then the prediction of the monsoon and the climate change.
Now you can move to prediction.
Prediction. Since monsoon controls our economy too, our economy is entirely dependent on monsoon, and then whenever there is a monsoon failure is there, some says that all bad events may occur simultaneously. So when you find it is in 1965, 66 and other time, what happened before that also? We have the Congress government was in power, and you find the Chinese incursion also was taken place, and also the failure of the rainfall, and then the crisis that is there. In 79, there was also a monsoon, the failure was there. So, and then in 79, because of the good run of the monsoon, the government anticipated a failure of monsoon, and they took effective measures to manage the drought situation. Okay. Now, so if we know in advance how the monsoon will behave, it will help the policy decisions. Okay. Secondly, day-to-day march of the season, if the prediction that it is how it is made, and then that will be useful for particularly agricultural operation, reservoir regulations and other things. So now the India Meteorological Department is the responsible for monitoring the monsoon, for issuing the forecast, and for giving warning or advice to the government. The India Meteorological Department headquarters is in Delhi. It has one Northern Hemisphere Analysis Center. That is, there they have a hub where all the data from all over the world is received, and then synoptic charts are prepared, analyzed, both numerical analysis and synoptic analysis are made. You understand the difference between the synoptic analysis and numerical analysis. Synoptic analysis means that from the data, maps are prepared at various levels in the atmosphere. One at the surface level, another is at different millibar surface level, millibar that is 750, 850 millibar, 750 millibar, 600 millibar. At each surface, what is the circulation pattern it is doing. And based on the circulation, they anticipate what type of weather that will come, and then using the synoptic charts, they make the forecast. Normally, in advance of 24 hours, the forecast is made in 3 times. One is a short-term forecast, and another is medium-range forecast, another is a long-range forecast. Short-term forecast, it is about 1 to 2 days in advance. That is about 12 hours to 48 hours in advance. 3 to 4 days in advance, it is the medium-range forecast. More than 5 days or 7 days in advance, that is the long-range forecast. That is the forecast, how it is behaving. Now, in the India, that there is a Northern Hemisphere Analysis Center which prepare the synoptic charts and then they distribute to the various regional meteorological center, and there is another headquarter office at Pune is located, India Meteorological Department. There also the charts are analyzed and then the forecast is made based on the synoptic conditions that is prevailing. Whatever the circulation pattern which I have explained today, if they are present, then or if they are absent, accordingly they will predict what type of rainfall that is likely to occur. The prediction is made on the synoptic chart. Second, it is with the help with the ability of computing very fast and computer facility, numerical weather forecasting is made. Every parameters is analyzed mathematically, models are created, and then the mathematical model is used, how the parameters change, and with the change in the parameter, what are the conditions that will prevail. That is the numerical weather forecasting. And then now, with the advance in the computer technology, then the charts are prepared very fast, and then it is able to disseminate more. So this they make the short range forecast. There is another organization under the Meteorological Department, under the Department of Science and Technology, that is called medium range weather forecasting. Medium range weather forecasting, that is mainly for agricultural purposes. For every district of agricultural officer, the medium range forecast ahead of 5 to 7 days in ahead, Tuesday and Thursday, that it is disseminated. And the agricultural officers are in consultation with the extension officers. They advise the farmers what steps to be taken depending upon the prevailing weather conditions. So there is a national medium range weather forecasting center which is located in Delhi. Then there is another one is in tropical meteorology institute at Pune, where they do research, mainly on research, and most of the climatological studies and the interrelationship that it is done, it is there in the Tropical Meteorological Institute, which is situated in Pune. And then each state has got a meteorological center which takes care of the particular state. At district level, they provide the information. Now, at the website, it is available, the forecast, and then the district level forecast also that it is made. Now it is possible to get point location forecast also, that it is possible, it is disseminated. It is the extrapolation of the forecast that is made in IMD by India Meteorological Department and extrapolating over the other area. So you have this forecast that it is then. Then the third, it is the prediction of the monsoon in advance. The next year or in the coming year, how the monsoon will behave. That attempt has been made over the last 100 years or so. From the beginning, that it is the Walker, he was one of the Indian meteorologists, and others, they were trying to attempt to predict what it is the possibility of the rain that it is occurring. 100 years, so much of development, still, to be frank, they are not very successful. They were able to predict, meteorologists were able to predict a good monsoon. But most of the occasions, they have failed to predict a failure of the monsoon, which is very important. That means our understanding of the monsoon circulation or the database on which the predictions are to be made are not that advanced. Still, it is at an empirical stage. And then that prediction it is made. Now, all over the world, there is an interest in predicting the monsoon. And then they have the global circulation models are created, and with the help of the model, they try to predict it. There are two methods are adopted in predicting the monsoon. One, it is a statistical parameter. By statistical methods, that it is they predict the monsoon, what it is called parametric approach. And then, so for example, if the rainfall during February, March, and if the snowfall over the Himalayas is very intense, very high in April, March, April, and rains are intensive, there must be a poor monsoon. There is one correlation. So, then the presence of El Nino. El Nino, you must be knowing about the Peruvian current that it is passing along the South American coast, along the Peru-Chile coast. If they are strong, then there is a possibility of a failure of monsoon. But over the years, when the analysis are made, only on 50% of the occasion, when El Nino is present, the monsoon also was poor. But another 50% of the occasions that even El Nino was present, the monsoon were good. So it is not one-to-one correlation. There is a probability of only 50% that is El Nino that is taken into consideration. So then you have the El Nino and Southern Oscillation. There are two phenomena that is used. One is El Nino, that is the change of the current from cold current to warm current. Another is the presence of high pressure over Darwin and high pressure and the pressure at Tahiti. They are interrelated. They oscillate. That is called the Southern Oscillation. So the combined word ENSO, ENSO, is El Nino and Southern Oscillation. That is also used in a statistical parameter to predict the monsoon. But so far, that is, at one time there were about 18 to 19 parameters were used in predicting the monsoon. That is, as I told you, the snowfall in the winter, snowfall in the European continent, then the position of the upper level westerlies, the position of the upper level easterlies in the month of April, and so like this there are about 18 parameters were used, and then that and using a method called ARIMA method, that the predictions were attempted. But over the years it is not that much successful. Now they have reduced the parameter. So the statistical approach, it is still not successful in actually predicting, particularly when there will be a failure of monsoon or not. Then the numerical prediction, that it is still in the modern stage. Now the India Meteorological Department still uses the statistical method of predicting the monsoon. Once they give it in March or March, then the beginning of May that they give, and midterm correction that is given in August, that it is given. So there is a prediction that it is made in the monsoon. Now, so this is still attempts are made. As I told you, it is the success rate is not that much encouraging. Now another is that prediction due to the climate change. The climate change is taking place, and then how does the climate change will affect the monsoon circulation? In the monsoon, most of the studies they indicate that they use what is called grid method of a modeling. So they have a grid about 5 kilometer by 5 kilometer or 2 kilometer by 2 kilometer grid, and in each grid they were able to get the data from satellite imageries and others, that the parameters that affect the monsoon circulation. And then if the sea surface temperature increases, what will happen? They use the model, and then they try to predict the monsoon. That is the climatic change, what will happen. Now when they apply the model to the past events, they were not very successful. But the general consensus are the two. It will be beneficial. That is because of a high sea level temperature, more convective activity, more evaporation, and then more circulation, it might increase the monsoon rate. But the increase there may be a slight increase or a moderate increase in the monsoon rainfall, but the way the rainfall may occur may not be that much encouraging. One, it is if there is 100 centimeter of rainfall, is the average rainfall over India. It occurs on an average on 100 days. 100 days. Now this 100 centimeter, let us say it increases to 120 centimeter. The 120 centimeter of rainfall, if it happens in 90 days or 80 days, the intensity of rainfall increases. Similarly, if there is a drought which occurs, so the intensity of extreme events may increase. Second, the frequency of occurrence of extreme events, both occurrence of rainfall as well as the amount of rainfall, they will be on an extreme. The frequency of occurrence might increase. That means we must have a better understanding of the monsoon, better ability to predict in order to manage our situation. That is what it is, the climatic change models broadly indicate. Many of you know about the Intergovernmental Panel on Climate Change. There is IPCC. They are working on that. And then the climatic change is how it is going to affect what are the circulation. That intense research is going on. Still no consensus has come on the what will happen to the monsoon circulation. So with this, I just talk, and I hope I made my talk legible and intelligible and useful. Thank you very much for your patience.
Exact date of bursting also not be predicted, no?
Pardon?
Exact date of bursting of monsoon.
I am not competent enough to answer your question because it is more theoretical, and then the meteorologists are the only one who are competent to answer the question. But all have some scientific basis. All the classical approach, and it has a scientific basis because it is based on observation, based on the empirical relation. One, it is the empirical relationship, another is theoretical findings. Now, most of the studies are still at the empirical stage. Because it is empirical stage, you cannot call it as unscientific. So that it is all or that one. The classical approach is of making the statistical correlation. Say for example, the depression, how the forecast is made. You see, then they follow the past synoptic analogy, and then they use that synoptic analogy for predicting the formation of depression. Because depression is the rainfall. Now, 50% of the depressions, they are the result of the passing low pressure from Thailand and Pacific. From Thailand and Pacific, the low pressures they just form, they get intensified, and then they move over the Bay of Bengal, head of the Bay of Bengal, and then they move. And then second, it is some people, they say the upper air divergence is intensified. What it is called the wind shear. When the wind shear decreases, then there is a possibility. That means that if the change in the velocity of the wind is not much and it reduces, it adds convection, and then then it causes the formation of the depression. So such empirical findings are there. With that they approach and then they make the prediction. So then the mathematical modeling, now it is being adopted. It has been there, numerical prediction, that it is there, that is no, absolutely it is a thermodynamic equations, and then each parameter, how it will change, what are the, at different layers, so that because so many millions of calculations have to be made, India was the first one to import the supercomputer. Mainly, USA agreed to give the supercomputer some 20 years before, mainly to assist in doing these calculations. So, still, the monsoon is so elusive, still it has not come into the grip of the meteorology. Because of the changes in the land use, changes in the assuring situation, and even the formation of the fort, and then the protective layer, the mangroves and others are given, they were removed. So that storm surges, because the cyclone damages due to cyclone is caused by storm surges, high velocity wind and high water, that is storm surges, water waves are entering. And because these mangroves and others are modified, these storm surges become more intense and reach at a much longer distance, created a rod of power. And thirdly, it is the time of the occurrence. It is they are little bit they didn't expect that this prime that is the cyclone will come. So with the configuration of the coast, you will find that near the delta, that the chances of cyclone crossing is more, because in Krishna Delta also it is there. Devi Taluka was completely washed off. So in the deltaic area, probably the configuration of the delta and then the presence of moisture and others might be drawing, but it is not. It is only a conjecture. Scientifically, we could not say what is the relationship. But the damages are more because of the wrong land use plan. The mangroves and the wetlands near the coast, they are all converted into fish culture and others, which accentuate the. In cyclone, we are making much advance of making use of the forecast, taking precautions and others. When Gopalpur, that is Paradipur cyclone when occurred, about 3 weeks before another cyclone crossed. At that time, the Andhra was supposed to cross the Andhra coast, but so Andhra government prepared itself to provide emergency relief and others to Andhra people. The people will be affected. But when the cyclone crossed near Balasur or near Odisha, immediately the government, without waiting for bureaucratic clearance and other things, rushed the relief materials to the people in Balasur area. They got relief quickly. In the cyclone which occurred about 2 weeks earlier than the severe cyclone which occurred here. So it is not very clear why it is there. Probably the delta configuration is here. And interact with the material. Second, the climatic part of it we can take care of. As I have told you that the monsoon, the climate change points out the occurrence of extreme events that are likely to occur. So we have to monitor locally. We have to prepare a climatology of the local area. We must have a proper record of the events that extreme events that have occurred. Secondly, we must be able to interact with the local people and know their local saying, their experience are to be recorded, and then help them in interpreting the weather forecast so that certain actions can be taken to minimize the hardship caused due to adverse weather conditions. For example, tsunami occurred, you all know. And then in Thailand, I suppose so, in one of the beaches, a small girl listened about the occurrence of earthquake in the Indonesia. She immediately told the holiday makers, those who are nearby, let us run. Because my geography teacher taught me that when so many years back, when severe earthquake occurs, the sea will recede and another tsunami will occur. Let us run away from the coast. They all ran. The 50-60 people saved their lives. So we do not know where the knowledge will be useful, and your awareness and other things there. Similarly, the local people in Andaman and Nicobar Islands, when the sea receded, you also recede. But whereas in Chennai and other places, we got much more beach. They went in, they were swept away. So this knowledge, it is your ingenuity how we can make use of it. But we got to make a record. And secondly, we may use the knowledge for practical ends, or we may use it for personal gain. As a person who taught climatology over the years, I have a few observations that I would like to make is What is the word climate? Means it is the angle of the sun's rays. Clima means it is the angle. That means you lean on the climate. Okay? The atmosphere provides you the protection. It protects you from the harmful radiation, and then it provides you the ambient temperature and the water necessary for the life to sustain. We depend on that. And what it says, it redistributes the heat that it receives. It doesn't accumulate. Redistribution is taking place. If the moisture is not transported from the ocean to the Indian, then rainfall will be much good. So the redistribution is taking place. So this has a life in our personal life also. Now you have the global meltdown, it is there. Why? Because the circulation is a wrong circulation. They made money out of money, and it is circulated among only a few people. And in this circulation there is a failure, and then the entire thing is, it is not distributed evenly. It is not distributed. So these are some of the philosophical conclusion we can observe it. See, the sun is there, sun provides the energy, and then the way the things, you have your sense of appreciation to the nature and your conscious awareness of how the nature affects us. Do we leave behind for the next generation a better world or not? That we can do. The climate change is taking place because of our way of living. Because the way of living that it is, we are changing it. Can we adopt a way of life which will minimize the conflict? So a person, I meditate sometimes on that. That is another aspect where one can use the knowledge of it. But as it is the interaction with people. If you have a scientific background, you can do it. Sorry, in my tiredness, I might be speaking a little bit.
Aru?
The last 1.5 hour, nearly 1.5 hour, we have been listening to our guest, Professor Sivaswami. So I am thankful, and I'm thankful to him for his delivery, his speech, valuable speech he has delivered to our students. And I hope to meet him in the future in this department, and I expect him to invite once again in the future, in the days to come. So I thank him once again, and I also thank my colleagues and all the students for attending this lecture. So thank you all.
When I am addressing you all, thank you very much for patient hearing. Thank you.
Thank you.